Neuromorphic chips are analog data processors inspired by the biological brains, which incorporates different types of chip designs and algorithms to mimic the way human brain works. The name of these chips can be broken into two parts. The first part is neural, which means it's relating to nerve or nervous system. And the second part is called morphic, which means having a shape, form, or structure. The design of these new chips enables itself to process massive amounts of information while only consuming minimum energy.
The purpose of these chips are vast. However, we will focus on three of the most important reasons these chips are useful. The first purpose is AI and machine learning. The high performance and efficiency of these chips allow the computer to learn more like biological organisms, allowing for increased learning. Efficiency is also an important takeaway of these chips. All computations are done in memory, which removes bottlenecks found in traditional computers. The efficiency and performance of these chips allow for complex machine learning algorithms to run locally instead of on the cloud. This opens the possibility for highly intelligent portable devices to exist in the near future.
Neuromorphic chips have been used in help to curb the spread of COVID-19. They were used to help improve the accuracy of antibody tests. Also, because of their low power requirement, neuromorphic chips are utilized for self-driving vehicles. Level 5 vehicle autonomy, which is driving without human interference, would also require AI-powered neuromorphic chips. Electronic skin systems have also been developed with neuromorphic chips, which could give prosthetics and other robots a sense of touch in the future. When worn, neuromorphic chips also have a lot of health benefits. They have the possibility to make memories last longer, to help avoid dementia, and manage emotions.
Now that we know where we can actually find these chips, who's producing them? Some of the major companies experimenting with them, the recognizable names, are IBM Corporation, HP Corp, Samsung, Intel, Qualcomm Incorporated, BrainCore, HRL Laboratories. However, the major players in the neuromorphic computing market include General Vision Incorporated, Applied Brain Research Incorporated, and BrainChip Holdings. And this is mainly because a lot more companies are getting into it because the neuromorphic computing market is expected to be valued at about 22,000 USD in 2021, but it's expected to reach about 550,000 USD by the end of 2026, according to markets and markets.com. Well, now that we know what neuromorphic chips are and a lot of what goes through with them, how can they change?
Today, neuromorphic chips can outperform any chip currently available in the market. A blog post published by a researcher at IBM Research describes their neuromorphic chip, True North, to be able to handle 1200 to 1600 frames per second, compared to only 160 frames per second, which is the speed of current chips. Neuromorphic chips will also continue the growth of the IoT. As stated in the MIT Technology Review, neuromorphic chips will be able to track an individual's vital signs and respond with treatments over time. Finally, neuromorphic chips will allow the creation of new AI for cars and robots, due to their high performance and low power consumption. For example, cars will be better able to recognize other vehicles and signs, and robots will be able to recognize voice recognition.